Welcome back to the Deep Dive. Today we're plunging into a forecast that's really got scientists talking. Winter 2025-2026.
Indeed.
The research we've looked at paints this picture of, well, a perfect storm scenario, setting up for a weak polar vortex, a significantly disrupted one.
That's right.
So our mission today is to unpack what that actually means for winter weather, across the Northern Hemisphere, and understand these big climate drivers that are lining up. Let's get into it.
Okay. First off, it's crucial to remember the polar vortex itself isn't new. It's fundamental, a huge, persistent, low-pressure area with incredibly cold air spinning around the poles.
Right. It's always there, basically.
Exactly. But the key distinction for understanding what might happen is its structure. There's the stratospheric part, way up, maybe 15 to 50 kilometers. That's the main driver, the long-range predictor. Think of it like a massive atmospheric flywheel storing all that cold.
Okay. A flywheel high up.
Yeah. And then there's the tropospheric vortex lower down where our weather actually happens. That's more like the surface expression of what the stratospheric flywheel is doing.
So if that high up flywheel gets weak, as the forecast suggests, what happens then? How does that weakness let the Arctic cold spill out towards us?
Good question. The main mechanism is something called a sudden stratospheric warming, an SSW.
Sudden stratospheric warming. Sounds counterintuitive if we're talking about cold outbreaks.
It does. But imagine this really dramatic warming event, maybe 50 degrees Celsius, sometimes in just days, but happening way, way up in the stratosphere.
50 degrees, wow.
Yeah, and paradoxically, this warming way up high often signals extreme cooling down here at the surface, but maybe weeks later.
How does that work? The connection?
Well, these SSWs are usually triggered by large atmospheric waves. We call them planetary waves, moving upwards from the lower atmosphere, maybe kicked off by mountains or strong weather systems. These waves carry energy upwards, and when they break, they disrupt the stratospheric vortex, warming it suddenly. That disruption then propagates downwards, changing the jet stream pattern in the troposphere.
So it messes with the jet stream down here.
Precisely. It often leads to a wavier jet stream, which allows Arctic air to plunge south. That's how you get that warm Arctic, cold continents pattern we sometimes see.
And looking at winter 2025-2026, the sources are saying it's not just one thing potentially causing an SSW, but this global triad, three things lining up.
Exactly. That's what makes this upcoming winter potentially quite special. It's the convergence.
So what are the three?
Okay, first, La Niña. A weak La Niña is forecasted for autumn 2025. We know that the cooling of the Pacific waters during La Niña tends to generate wave patterns that travel up to the stratosphere.
And that increases the chances of an SSW.
It does. Historically, La Niña winters see SSWs maybe 60 to 75% of the time, so it definitely loads the dice.
Okay, factor one, La Niña. What's next?
Second is the Quasi-Biennial Oscillation, the QBO. It's this pattern of winds high in the tropical stratosphere that flip-flops direction roughly every 2 years or so.
Right, the QBO.
And the forecast is for it to be firmly in its easterly phase in the lower stratosphere next winter.
And why is the easterly phase important?
Because the easterly QBO acts like a sort of gatekeeper. It narrows the pathway for those planetary waves heading towards the pole. It's called the Holton-Tann effect.
So it concentrates the wave energy, makes it hit the vortex harder.
You got it. It makes the vortex more susceptible to being disrupted by those waves, including the ones potentially generated by La Niña.
Interesting. Okay, La Niña, easterly QBO. What's the third part of the triad?
The third piece is Siberian snow cover. There are some early indications, still early days, mind you, but pointing towards potentially extensive snow cover across Siberia in the autumn.
And how does snow in Siberia affect the vortex way up high?
Well, lots of snow means a very reflective surface, high albedo. This cools the land underneath, which helps strengthen the Siberian high-pressure system. And a strong Siberian high is known to be a potent source of those planetary waves that travel upwards and, you guessed it, weaken the polar vortex.
So it's like La Niña and the Siberian snow are both sending waves up, and the easterly QBO is making sure those waves hit the vortex more effectively.
That's a great way to put it. It's not just additive, they interact. The sources talk about non-linear interactions amplifying the effects. It's like a coordinated assault. The QBO might even help La Niña's influence kick in earlier, for example.
Right, it's the synergy that's key.
Exactly. Synergy is fundamental here.
So bringing this down to Earth, what does this potentially mean for your winter? We've heard polar vortex in the news before, like that really cold winter in North America. 2013-14.
Yeah, that certainly brought the term into the public eye.
Or the beast from the east in Europe in 2018. Is that the kind of thing we're talking about?
Potentially, yes. The outlook for 2025-2026 suggests a significantly increased probability, not a guarantee, but higher chances of recurrent high-impact cold air outbreaks.
Whereabouts?
Primarily across the central and eastern United States, southern Canada, and also across northern, central, and western Europe. We could also see increased snowfall in places like the U.S. Midwest, for instance.
So a winter of contrast, probably. Very cold in some places, maybe warmer elsewhere?
Very likely. A wavy, disrupted jet stream typically means strong regional contrasts. You get these pockets of extreme cold plunging south, but also ridges of warmth building in other areas.
Okay, so summing up, it sounds like there's pretty high confidence, based on these converging factors, in a dynamic, potentially quite severe winter ahead for 2025-2026.
The confidence is high that the drivers are lining up for a weak vortex state. The dice are loaded, as some forecasters might say, for major cold outbreaks. But
There's always a but in forecasts.
always. The exact where and when of specific cold snaps, that remains the challenge in long-range prediction. We're talking probabilities here.
Understood. Still, it gives us something to think about. Let's start with the basics, maybe. The atmospheric architect itself, the polar vortex. What exactly is it?
Right. It's crucial to remember this isn't some new weather phenomenon. The polar vortex is fundamental. It's this huge, persistent area of low pressure and cold air that sits over the poles. But for understanding winter forecasts, it really helps to think of it in two parts. You've got the stratospheric polar vortex way up high, maybe 15 to 50 kilometers up. That's the big, coherent driver. Think of it like a massive atmospheric flywheel, storing all that cold.
A flywheel, okay.
Storing cold energy.
Exactly. And then below that, down where our weather happens, that's the tropospheric polar vortex. It's basically the surface expression of what's happening with that flywheel way up high.
Got it. So the state of the stratosphere really dictates things down here. So if that flywheel, the stratospheric vortex, becomes weak, what does that actually do? How does the cold escape?
Yeah, good question. The main way this happens is through something called a sudden stratospheric warming, or SSW.
Yeah.
And it is dramatic. We're talking rapid warming, sometimes 50 degrees Celsius in just a couple of days, way up in the stratosphere.
50 degrees, wow. But warming up there, how does that lead to cold down here? Seems counterintuitive.
It does. It really does. That's the paradox. This stratospheric warming often comes before major surface cold outbreaks, maybe weeks later. It's triggered by these huge atmospheric waves, planetary waves, often kicked up by things like big mountain ranges or even sometimes land-sea temperature contrasts. These waves travel upwards, hit the stratosphere, cause that warming, and that sends a signal back downwards. It disrupts the jet stream, makes it wavier, and that allows the frigid Arctic air normally locked up by the strong vortex to spill south. That's how you get that warm Arctic, cold continents pattern.
Okay, that makes sense. The disruption high up changes the flow down low. And for this coming winter, 2025-2026, the research points to this global triad. Three big things happening at once.
Exactly. A convergence of three sort of independent climate drivers that all seem to be pointing towards a weaker vortex.
All right, let's break them down. What's the first one?
First, we're looking at a weak La Niña developing, likely in autumn 2025. That cooling in the Pacific, it sets up specific atmospheric wave patterns that tend to travel upwards and, well, poke the vortex. Historically, La Niña winters have a much higher chance of SSWs, maybe 60-75%.
Okay, so La Niña loads the dice for an SSW.
Number two is the QBO, the Quasi-Biennial Oscillation. It's this pattern of winds high in the tropical stratosphere that flips direction roughly every 2 years or so.
Yeah.
The forecast is for it to be firmly in its easterly phase in the lower stratosphere next winter.
Easterly QBO. Why does that matter?
Because the easterly phase acts like a gatekeeper. It sort of narrows the pathway. The technical term is the Holden-Tan effect for those planetary waves we talked about. It focuses the wave energy, directing it more effectively towards the pole, making the vortex more susceptible to disruption, like focusing a beam of light.
Interesting. So La Niña provides the waves, and the easterly QBO helps channel them towards the vortex.
Precisely. And the third factor,
the third element of the triad.
Siberian snow cover. Early signs suggest we might see unusually widespread snow cover across Siberia this coming autumn. Lots of snow means a very reflective surface, high albedo. That cools the land beneath, strengthens the Siberian high-pressure system, and that also generates powerful planetary waves that travel up and weaken the vortex.
So you've got La Niña stirring things up, the QBO focusing the energy, and potentially extra Siberian snow adding even more wave energy.
That's the picture, yes.
And you said earlier these aren't just additive, they interact.
Correct. It's not just 1 plus 1 plus 1. These factors can amplify each other. For example, that easterly QBO doesn't just steer the waves. It can actually make the La Niña impact felt a bit earlier, and it makes the atmosphere more sensitive to those surface anomalies, like the Siberian snow. It's a synergistic effect. A coordinated assault, as some sources put it.
A coordinated assault on the vortex. Okay, so bringing this down to Earth, what does this likely mean for people's actual winter experience? We remember terms like Polar Vortex hitting the headlines back in, 2013-14, and the Beast from the East in Europe in 2018. Are we talking about that kind of potential?
That's the potential, yes. The outlook for 2025-2026 suggests a significantly higher chance of repeated high on bad cold air outbreaks. We're looking particularly at the central and eastern U.S., southern Canada, and also across northern, central, and western Europe. Could also mean more snow in places like the U.S. Midwest. But it'll likely be a winter of contrast. That wavy jet stream means some places could be unusually warm, while others are locked in deep cold.
Right, so high confidence in a dynamic, potentially severe winter overall, thanks to this alignment. But are there, caveats, things that could change this picture?
Absolutely. Long-range forecasting always has uncertainties. While the background state, the dice are loaded for cold outbreaks, pinpointing exactly where and when those outbreaks will hit is still very challenging. Small shifts in any of these drivers, La Niña intensity, QBO timing, snow extent, could alter the regional outcomes. Climate is complex.
Of course. The dice are loaded, but it's not a guarantee for any specific location just yet. Well, it certainly gives us a lot to think about. It makes you wonder, doesn't it, how preparing for this kind of warm Arctic, cold continents winter might change how we view seasonal swings and maybe even the bigger picture of climate impacts. Something to ponder. Thanks for breaking that down for us. We'll keep watching this as the season gets closer. Join us next time on The Deep Dive.